Section 4.3 is on graphing linear equations in two variables using intercepts. So we had kind of talked about that a little bit before. We noticed that if we were going to look at something like 3x minus 2y equals 12, we noticed that determining the intercepts is pretty straightforward. We're just looking at if x equals 0, we know that we're going to get the y-intercept. We're going to get, then we get 3 times 0 minus 2y equals 12, so we get 2y, negative 2y equals 12, and so that means that we can divide by negative 2, and we see that y equals negative 6. And so that's going to be the y-intercept. If x equals 0, y equals negative 6, that's where we intercept the y-axis. If y equals 0, then we're going to get 3x minus 2 times 0 equals 12. So we get 3x equals 12, divide both sides by 3, and we get x equals 4. And so we notice we can graph those intercepts. We notice we can graph 0, negative 6. We can graph 4, 0. And all we need to graph the line is 2 points. We connect the 2 points, and we have our line. So we can do that with pretty much anything. We notice that any linear equation in two variables, we notice that if we had had 3x plus 5y equals 30, we'll get x equals 0 tells us that 5y equals 30, so y has to be 6. Y equals 0 tells us that 3x equals 30 divided by 3, x is 10, and so we notice we can plot our points. We've got 0, 6, and we've got 10, 0. So there's 10, 0, there's 0, 6, and we can connect the dots. So we notice that if we had tried doing that with slope-intercept, we would have ended up getting 5y equals negative 3x plus 30. We would divide by 5. And we get y equals negative 3/5 x plus 6. And so we notice that if we already have slope-intercept form, finding that point 0, 6 and then using the slope of negative 3/5 is probably easier. That said, if we have it in standard form and all we need is what the line looks like, we may not need to get slope-intercept. So if we're kind of halfway between, if we had something like 2x minus 4y plus 8 equals 0, the question of whether to use that to get slope-intercept form or to use these intercepts is kind of a matter of preference. So we can either look at it as 2x minus 4y equals negative 8 after we subtract 8 from both sides, and then we can use intercepts. We're going to get x equals 0 tells us that negative 4y equals negative 8, and so y equals 2. We get the point 0, 2. Y equals 0 gives us 2x equals negative 8, so x is negative 4, and we get the point negative 4, 0. So that's going to graph as equals negative 4, 0, 0, 2, and we get that line. Or we could have said negative 4y equals negative 2x minus 8, divided both sides by negative 4, and gotten y equals 1/2 x plus 2. So which one of those is easier? About the same amount of work either way. So it's really a question of personal preference. So we noticed that if we needed to get this y-intercept, if we're looking, well, it winds up being pretty straightforward regardless. Let's do one more example of this. If we had something like 2/3 x minus 4/5 y equaled, let's make it 8 again, we notice we have two choices. We could do this the hard way. We could look at if x equals 0, we get negative 4y, negative 4/5 y equals 8, and then multiply both sides by negative 5/4. So we can take y equals 8 times negative 5/4, and that's going to give us negative 10. If y equals 0, we get 2/3 x equals 8, so x equals 8 times 3/2, multiply both sides by 3/2, so x is 12, so we end up getting 0, negative 10, negative 10, and 12, 0. Alternatively, we could have looked at that 2/3 x minus 4/5 y, and we could have multiplied both sides by 15 to clear away denominators. So we wind up getting 10x minus 12y, whoops, we lost the y, there we go, equals 120, and then we notice that this gives us slightly bigger numbers, but now we can say x equals 0, tells us that negative 12y equals 120, so y is negative 10, and if y equals 0, then we get 10x equals 120, and so x is 12. So same result. It's one of those cases where we have to work a little harder with bigger numbers, but conceptually it ends up being a little bit more straightforward. We don't have to work quite as hard. So also, if we had something like y equals negative 3/5 x minus 3, and we really want to do that with intercepts, we can still do it. We notice that if x equals 0, then y equals negative 3/5 times 0 minus 3. And so we get the point 0, negative 3. So that's easy. But then if y equals 0, we have to work a little harder. Then we get 0 equals negative 3/5 x minus 3. We have to add 3 to both sides. So we get 3 equals negative 3/5 x. Then we have to multiply both sides by negative 5/3, the reciprocal of negative 3/5. Fortunately, that means we get negative 5 equals x. So we notice we can still do it. It's just probably easier to do it with slope-intercept form. So we have 0, negative 3, negative 5, 0. But then we also notice we could have just used the y equals negative 3/5 x minus 3 to see that the y-intercept was 0, negative 3, and then because it's slope of negative 3/5, we go up 3, back 5. So, again, the question of whether to use slope-intercept form or use the intercepts generally depends on what we're trying to do.